I don't mind tornado drills. I hate the intruder drills.
Man, I do not want to.
Okay, so here we go. We're going to zip through these last 6. We have L and X. Am I right? Am I in the right spot? Natural logarithmic function. Here's what I want you to do. I want you to put an asymptote at x equals 0. I want you to put an intercept at 1, 0. And then I want you to go up and out just like this. So we come down this way and get closer to the asymptote, and we shoot out. That is your logarithmic function. Okay? Now, the next two are sine and cosine. The grid is really small, so why don't you count up, I don't know, 3 or 4 blocks and call that 1, just to spread it out a little bit, and then go down the same amount and call that -1. If we try to go with just the blocks, it's going to be all squished up. Okay, now I want you to put a dot at the origin, and I want you to make a hill and a valley, a hill and then a valley. And you're going up to wherever you put the 1 and down to wherever you put the -1. So you got a hill and then a valley. And the same thing is in this direction. That is your sine curve. Everybody good? Now, when we do this one, we're going to do the same thing. So count up and put a 1 and a -1, just like you did. This time, though, don't start at the origin. This time, start here. Start right here. And then come down. Because your hill's going to look like this. And then make your valley. So the sine and the cosine are both hills and valleys, but the starting point's different. So here's how I remember it. You remember however you want, but you gotta be able to tell these two apart. I remember original sin. Original sin. And that reminds me that the sine curve goes through the origin. That's how I remember it. You remember it however you want, but you do have to keep these two apart. We will be doing a lot of graphing later on, but we will be doing a lot of graphing around Christmas time of sines and cosines. Okay. This one you did a lot with last year. Absolute value. You remember what it looks like. V. You remember that absolute value V? This is the greatest integer function. On your calculator, it's INTX. In a textbook, it's usually written this way. These are both ways of writing the greatest integer. I'm going to do it up here so I have more room. This is a weird one. I want you to put a solid dot at the origin again. And then 1 block over, so 1 block to the right, put an open dot. And then connect those. Then go up 1 block and put a closed dot. And then over with an open one. So you're going over one, up one, over one, up one, but you're coloring those in. Am I making sense? Are you able to do this on your paper? Are you getting something that looks like that? Yours will be more squished up because your grid is so small. But the important thing is, you start with a closed dot at the origin, and then we go over to the open, and then straight up closed, over to the open, straight up, and so on. Called the greatest integer function. Okay, we got that one? Okay. Then the last one is the logistic function. Its equation is kind of hard. It's 1 over 1 plus e to the negative x. And that e is the same as in your exponential. Remember we talked about that Euler's constant in the exponential, that's the same. This guy, put an asymptote at y equals 0, that is the x-axis. And then go up a ways, however far you want, but call this y equals 1. But go ahead and just go up several blocks so you have an open picture. Call it 1, that's a 1. And then you're going to draw a squiggly that on the left comes down, 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 getting closer to 0. And on the right goes up, 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 getting closer to 1. What other curve is a squiggly like that? Do you remember? Not squared, cubed. Only the cubed one is up vertical. This one is squiggling sideways. Okay, folks? All right, that's your BFFs. Now, we're in our 1.3 notes. And we're going to do some sketching. Now, we'll do a quick review of the rules before we start. But I know you guys spent a lot of time with this last year, so I don't anticipate much need for all this, but we're going to review, okay? So I'm going to pick a function, maybe our favorite absolute value. There are basically 4 ways that we can change the absolute value function. Change its position. Do you see the difference between these two? When the 2 is inside the problem, so whether it's an absolute value or a cube or anything, if it's inside the problem, it goes left or right. A plus 2 inside the problem goes left. 2. This one would go right. 2. These are the rules that you gotta know. If you're adding on to your problem or subtracting your problem outside the problem,
Up or down?
outside, it goes up or down. And when it's plus 2, it goes up and down, or negative 2 goes down. Is that okay? So now, we're going to sketch these variations of our BFFs. So I'll leave the rules up here. You have your BFF sheet. You don't need your sheet though, because you know this is a V. And instead of being from the origin, it's going to be left one. So you're going to mark this point, -1, 0, and you're going to draw your V, and you're done. That's it. This is not a V. What? This isn't a swoosh either. This is a parabola. U, yeah, parabola. And normally it comes out from the origin, but this one has been moved right to. Very good. You do, guys do remember. I'll tell your teachers, they'll be so pleased. Make sure you label that new vertex, wherever it is. Now, this one we just talked about today, but you don't know it yet probably. So let's refresh our memories. On your sheet, we have an asymptote at x equals 0 and a dot or an intercept at 1, 0. Okay, this is my normal picture, guys. Okay, what's happening? Down 2. So what does that mean? Going down 2. Will that change the asymptote? No. But it will change that point now, right? Where's that point going to be? Now it's going to be at 1, -2. Now you guys, the shape is the same. So it's still coming up and arcing out. Now it looks like that.
Will the X always be 1?
If you're going up and down, now not if you're going sideways.
Okay.
Because if you went sideways, then it could be 2 or something, right? But yeah, if you're going up and down. Anybody else have a question about that? That's kind of a weird one. We okay? All right, now we've got, ah.
Whoa.
First of all, look at, this is called the reciprocal function. What does he look like normally? Just a plain old reciprocal. Asymptote here, and these. We need to have these memorized, guys. For now, look at your sheet. Is that okay with everybody? That's in your sheet. Okay, now what have we done? We put a negative on it. Who remembers what that means? Negatives flip you upside down, right? So instead of this being in quadrant 1, he's going to be down here in quadrant 4. The asymptotes aren't changing, but the curve now will be down here. And then that one will be up here. Is that okay with everyone?
Sure.
I love it. Thank you. Okay. If you don't remember what a square root looks like, look at your BFF sheet and then tell me what we're doing to this square root. How is he moving?
The right one?
Oh.
Like a little upward
Yeah.
swoosh.
Okay, but somebody said he's moving right one. A move right one would look like this.
Up one.
He's going up one. So, The normal one starts at the origin and goes up and out. So this one is going to start here at the point 0, 1 and go up and out. Make sure you label that point. Aiden, you okay, honey? Okay. Oh, I want to check that. All right, next we have x minus 2q. Okay. Which way are we moving?
You're going down.
We're going right, right? We're going right. Do you remember what a cube, this is a cube. Remember, he's the one that squiggles at the origin. So now he's going to squiggle over here. So I'm going to come up. There it is. Probably today was the first time you've seen a sine curve. So I'm going to go ahead and just refresh my memory. A sine bounces hills and valleys between 1 and -1. It goes through the origin, so it looks like this. Okay, that's what a sine looks like. Now, how have I changed it? What have I done? I moved up 2. Now, you guys, if it helps you, feel free. These aren't asymptotes, but like this. Jalen, why is your head down, honey? Jalen. Dude, are you awake?
Yeah.
Okay. We go down to -1 and up to 1. These aren't asymptotes. They're like the floor and the ceiling. Now those got moved because we went up 2, right? So where's the new floor? The new floor, remember everything went up 1, up 2.
3 and 1.
So it's now at 1. This is the floor. And where's the ceiling?
Was 3.
At 3. Now remember, the origin was the beginning point, right, of the hill? But it got moved up 2 also, so isn't it here now? So now I'm going to draw my hill and my valley, and my valley and my hill. Take a look at that. I know that's brand new to you. So you might want to just take a second look at it, make sure you figure out what in the heck I'm doing. Does anybody have a question about that? You okay? Everybody's awfully quiet. You sure you're okay? Okay, I worked on your test over the weekend, and you're gonna have to do something like this on your test. Oh, I know, we still have more of those. I have to be ready.
You guys, what is it?
We'll have a quiz, yeah,
This week?
maybe. We'll practice for it. We'll do a practice in our next class, and then take the quiz. So yeah, it will be this week. All right, so e to the x minus 1. All right, so this is our exponential. And what have we done to it? Moved it down 1. Now, I always like to draw my original. You don't have to do this, there's no rule that says you have to do this, but I like to draw my original and then do whatever I need to do. So what did you say? I was gonna take it down one? So the normal asymptote is right here on the axis. The whole thing's coming down one, so the asymptote's coming down one. So it's now gonna be at -1. The intercept was at 1. Now it's gonna be at the origin. And then I got my shape. Remember, nothing we are doing is changing the shape. All we're doing is either turning it upside down with a negative or picking it up and putting it somewhere else. Tell me about this guy. What's he gonna look like?
It's gonna go down.
He's gonna look like an upside down. His vertex is still at the origin because I didn't do anything to move it. Right? All right, we're gonna skip this next part. We've talked about those terms, so we're gonna skip that and go on to number 3. So get your calculators out. Let's zoom 6. Zoom 6. That will give us our standard window. And then you remember, type y equals, and type in your equation. So x squared minus 5, hit graph. What shape did you get? Could you have done this without a calculator?
Yes.
Absolutely, because you know it's a parabola, and what does the -5 do? Down 5. Okay. What's the domain?
All reals.
All reals. Negative infinity to infinity. And then what's the range?
-5 to
-5 to infinity.
Would it be bracket?
Yes, it would be a bracket at -5 because that point is included, right? Okay? So, now let me write that just so we can. So our domain for problem A, problem A, our domain is this, and our range is this. Everybody okay with that? All right, let's take a look at B. B is not quite as easy. So you have an LN button, find your LN button, and then type x plus 6. And hit graph. Now, what Elijah's pointed out is, again, you could have done this without a calculator because you know what an LN looks like. And what does the +6 do? Left 6. So you know, without a calculator, you know that shape is going +6. So you actually got an asymptote over here at -6. You don't see it on your calculator, but it's there. And our curve looks like that. That's what you see on your calculator. It doesn't go all, it looks like it doesn't go all the way down, but it does. It does. Okay?
So
Are we
say,
good with that?
is it crossing the
Does the name mean open bracket
crossing
negative
the 5?
six?
Okay, let's start, let's start giving some good questions.
You don't
Let's
include
talk
negative
about
six in
that.
that.
You need to
Never
turn your
actually
plot
fits.
on.
Maybe just all those, yeah.
Okay. All right, so what would you say the domain of this guy
Always,
is?
open bracket is six, bracket negative six to.
Negative 6 to infinity, or to infinity.
Yeah.
Why is it an open parentheses?
Asymptote.
Because there's an asymptote there. There's an asymptote there.
On my calculator, like stops at negative or.
It looks like it does, but it doesn't. It keeps going. Remember, there's nothing as perfect as the human mind, right? So we're better than the calculator. We know what a logarithm looks like. The calculator's doing its best. Okay. What is the range of this guy? Negative infinity to, doesn't this go forever?
Yes.
Yes. So very, very good. And again, it's nice to have the calculator, but you don't really need it for these problems because you know what it looks like. Okay, let's try this one on our calculator. 1 over x. Stop yawning. Plus 3. Did you get something that looks like you would have anticipated it to look? Because you know that 1 over x looks like this.
Yeah.
So when you pick that whole thing up 3,
You go down to
it's still going to have an asymptote here, but this one is now going to be up here at 3. And you're going to have this curve and this curve. So is everybody okay with that? Now this one is tricky. In terms of domain and range, I want you to think about it for a second. And then give me your best shot. What do you think your domain
All
and
real.
range are?
Domain is all real.
Actually, it's not.
Oh.
Ronan?
Negative infinity to 0.
Whoa.
And then oh, there's asymptote zero down.
There's an asymptote to 0,
I
right?
didn't know that.
So we go from negative infinity to 0. We have to skip 0. Can't include an asymptote. And then 0 to infinity. Nice work. Ronan, good job. Now, tell me about the range. Now, range is up and down. Okay, take a shot.
Negative infinity to 3, and then have that as a parenthesis, and then u to 3 to positive infinity.
Bingo. You guys are all stars. That's exactly right. Why can't that 3 be included? Because it's now an asymptote. That's a tough one. Good work. Again, we're going to do this on our calculator, but you don't need it. Tell me with that, before we go to the calculator, tell me what this is going to look like. It is going to be an absolute value v, moved right 4. All right, let's graph it and see. Okay. Now, to get absolute value, go to math, your math button, the button called math, and then go over to number. In the top menu there, go over to number and see the very first thing is abs. Press it and then put inside there whatever we need, x minus 4, and hit graph. And sure enough, did you get your V? What are you doing? On vacation? All right, what's your domain? Negative infinity to infinity. What's your range? 0 to infinity, and you're bracketing in the 0. Okay? Last one. These are hideous. I don't like greatest integer functions. Let's do this one on our calculator and see what it looks like.
Where's the button?
I'll show you. Hang on a minute.
Oh,
X over 2. Okay, so go to y equals, just like you always do. Go to math again, and go to number. Absolute value was option 1, but look down the list. Do you see int? So we get int, and put x divided by 2. Now, this is another imperfection of the calculator. The calculator cannot show open dots. It also cannot lift its pencil. So it looks like all those steps are connected. At least on mine it does. Does yours, are they separated on yours?
Yeah.
Okay, they made an upgrade in the newer calculator. You can't see open dots though, can you?
No.
Okay, so we know where the open dots are. Here's my question to you. Patton, are you okay back there, honey? What's different? Can you see anything different about this than the one I graphed on the board?
out to the right, to
The steps are
the right.
longer.
Oh,
Aren't they longer? You still have one at the origin. It's hard to see because it's right on the axis, but they're too wide. What's my domain? Everything. Negative infinity to infinity. What's my range? This is tricky. Only the integers. So for the range for this problem, guys, you have to just say integers. You can't put it in a like interval.
Would the range always be integers on this? Like,
On the greatest integer function, yeah. Because that's what it is. It's just rapid. All right, we okay with that? All right. Now, number 4. Number 4 is what we call a piecewise function. Really need people paying attention here. So we are going to sketch and list any discontinuities. And we're not doing it on our calculator. We're doing it by hand. All right, so here we go. Does the word piecewise make sense to you? The function is in pieces, and we are going to graph it in pieces. Every time you have a piecewise function, almost, there's going to be a break in it. And the break is going to happen right here. So first thing you need to do is look right here and say, okay, my graph is going to be broken at this point. Now I'm not drawing it as a line because it's not an asymptote. That is just my reminder that at 0, my graph is broken. Okay. Now, this may be different than the way you graphed these last year, so however you graph it is fine. This is the way I do it. With my pink marker, I'm going to graph y equals x. What shape is that? Linear right through the origin, so it looks like this. Can everyone agree that's what it looks like?
You want to see that? Where's the same? It's the same example.
No, this is, we're graphing. This is it. Now, guys, notice it crosses my crack, my break line. It's like a crack. crosses right there. And it crosses in a solid dot because of this. So I have a nice big dot, colored in. And now I'm gonna keep the part of the line that X is less than 0. So that's this part, the left. This is the left side of the picture. So I'm gonna keep the left and erase the right. So that is my first piece of my function. This tells me what to keep. I don't get to keep the whole line. I only get to keep the part of it to the left. Now, what shape is this? Parabola. And that one actually has an open dot right there, but it doesn't matter because that dot's already been colored in. But technically, the green is an open dot. And what am I gonna keep? The right side of it. So there is my picture. Now, are you ready for some wackiness? There are no discontinuities. Even though I thought my picture was going to be broken, since the open dot is right on top of the closed dot, I actually could draw this without lifting my pencil. You see what I mean? They connect. They don't usually connect. Our next example, they won't connect, probably. Okay, so there we go. Piecewise function. All right, let's try the next one. All right, this one has a break here. Okay, at 0 again. This tells me where the break is. This says I'm going to keep the left side of this picture and the right side of this picture. What does that look like?
Bottom right, third quad.
This is a reciprocal function, and normally I would draw a piece here and a piece here, but because I've already figured out I only want the left piece, I'm going to draw them right there. There it is. Now take a moment, let that settle. Technically, I got another piece over here, but I can't include it. I just have to erase it. What's this guy look like? He has a solid dot right here, and he shoots up and out. And since the whole shebang is to the right, that's it. There is your piecewise function.
Do you ever have to graph the main range from piecewise?
Do you always have to what?
Do you ever have to graph the domain?
Well, we can talk about domain range. Why don't we do
Is that
that?
gonna be a question?
Could be. Anything can be a question. What's the domain here?
Negative everything.
Everything. Yeah. Domain is your x's. And this is everything negative, this is everything positive and 0, so that's everything. Range, let's see, what's my range?
Everything.
It is also everything, J.S. Very good. Now, some of you are thinking, wait, Mrs. Ford, there's an asymptote here. There is, but then we put a dot over here. So here we got everything positive, here we got everything negative, we're good, we got it all. All right, you and your partner, try C. Try C, you and your partner.
Yeah, oh, it's.
This one's pretty hard.
Pretty hard.
Especially with the zero.
This was a little more complicated because there's two things over here. That means my picture is broken twice. It's broken at 0 and it's broken at 1. It's broken twice. All right, so let's look at this. This is a line. I'm going to turn it around and write it the way I normally see it, like this. So it has a slope of -1 and a y-intercept of -3. So let's see. So -3, and then up 1, left 1, up 1, left 1. Okay. So here's my line. That's the whole thing. I just do the whole thing. But what part of it do I want? The solid dot at 0, and then I keep the left, so I really don't even want this part. So there's the first part of it. Does that make sense to everybody? You're going back to first year algebra, you're graphing a line, but you're only keeping part of it in this function. Okay? Now, what in the world does this look like? Y equals 1. That's what it says. What is y equals 1? A horizontal line? Right? It intersects both of my squigglies with open dots. And what part of it do I keep? Not left, not right, middle. I keep the part between 0 and 1. So I only keep this part of my line. Okay. What does that look like? Parabola. Vertex at the origin. There it is, right? It has a solid dot at 1. And what part do I keep?
Everything up above.
Just that. So this all goes away. Wowsy, wowsy, wowsy.
Wait, so this is
What?
and then domain.
What's my domain? My domain is all real numbers.
That's a hard one.
Wait, why is
And then the range
the parabola not as a
It
is
is a two.
is negative.
But you only keep the part. Oh, greater than one.
Greater than one. All right, guys, 1.3 due on Wednesday.
What?
On Wednesday, tomorrow, I see you tomorrow. Tomorrow, we will do a practice quiz, and then on Wednesday, we'll take the real quiz, okay? So homework is due Wednesday, and we'll have a real quiz on Wednesday, which we will practice tomorrow.
run it through the hand.
Got it?
Easier for you to hit.